Integration of exponential function. So the formula for the integration of exponential function is e to the u du is equal to e to the u plus c. Okay? So, for example, you have the integral of e to the 4x dx. So here, again, your u is the exponent of your e. So if you let your u as 4x, the du with respect to x is equal to 4. So therefore, by substitution, this e to the 4, this e, will copy the integral, you have here the e, 4x is u, and you want an expression for dx. So from here, you can see that the du is equal to 4 dx, the dx is equal to 1 over 4 du. Okay? So therefore, that is now du 1 over 4 is your dx. So this, because it's already in this format, so we are now ready to integrate. So this is going to be equal to 1 over 4 e to the u plus c. So that's, then just plug in back the 4x. So that's 1 over 4 e to the 4x plus c. Let's try to take a look with another example. Suppose I have e to the integral of 3x minus 1 dx. Okay, so here you let your u as the 3x minus 1. Therefore, the du dx is equal to 3. So by substitution, there is no integral of e. 3x minus 1 is your u. The dx is equal to, from here you're going to say du is equal to 3 dx. The dx is equal to 1/3 du. So that is now du, that is 1/3. So this is now equal to 1/3 eu plus your c. Or you plug in back the u, which is 3x minus 1 plus c. So that is the final answer. Let's try to have the next example. Suppose I have the integral of e to the x squared times x dx. Okay? So this is now your integral. So you can use substitution again to find this, because if you let your u as equal to x squared, the derivative of u is equal to 2x. The derivative of du dx is equal to 2x. Therefore, the du is equal to 2x dx. Right? So therefore, this part here, by substitution, copy the integral symbol. So that is now e. Your x squared, you let us to be u, and then you need an expression for x dx. Okay, your x dx is this one, so therefore your x dx is equal to 1 over 2 du. So that is du, that is 1 over 2, so therefore it's equal now to 1/2 e to the u plus c. Plug it in back the original value of your u. So y is equal to x squared e to the x squared plus c. Let's try to have one more example. Suppose I have the integral of e to the sine x times cosine x dx. Okay, so this one could be solved by, you let your u as sine x. The derivative of u with respect to x is cosine x. So therefore the du is equal to cosine x dx. Therefore you can now rewrite this as the integral of e. Your sine x is your u. You need an expression for cosine x dx, and the cosine x dx is equal to du. So that is now du. So therefore the final answer is e to the u plus c, but your u is sine x, so it's e to the sine x plus c. Let's try to have another example. So this may not be substitution, but maybe let's just try. Suppose you have the integral of e to the 2x minus 1 to the e to the 2x minus 1, but this is raised to the 2, and that is dx. Here, here we cannot use the substitution anymore. Why? Let's see, because if we can, because this is a power. Let's see. Let's check if you can rewrite this one into this format. Okay? So if you let your u as equal to e to the 2x minus 1, your du with respect to x is equal to, what's the derivative of this? That is 2e to the 2x, and the derivative of that one is 0. So when you use integration, when you use the substitution now, so this part, just copy that integral. This is going to be your u. That's going to be raised to the 2. You need an expression for dx. So from here, your du is 2e to the 2x dx. You only need an expression for dx. So you're gonna be thinking of du 2e to the 2x. If you put it here like du there, divided by 2e to the 2x, this cannot be solved because there is still x. Okay? When you use substitution, all it could be a single variable, and it should be more simplified. In this case, from in this case, after the substitution, it becomes more complicated. So here, we cannot use the direct substitution. So what we can do is to simplify this first. We can expand it. So how shall we do it? So expand that one as e raised to the u when you square this. So e raised to the 4x, alright, minus 2e to the 2x. Then you square that one, that is plus 1. Then that is dx. Therefore, the integral of this, okay, is e to the 4x. So well, by substitution, this is your u for x. So what you're gonna do is just simply reverse it. 1 over 4, okay? Minus 2e to the 2x. Then you take the derivative of that is 2. Then you reverse that one, 1 over 2. The integral of that is x, okay? Then you have there plus c. So therefore the final answer is 1 over 4 e to the 4x minus e to the 2x plus x plus c. So this one is the integral of that. Okay? Let's try to have one more example. We still have, okay, let me just get a piece of paper here. So let's say, for example, that I have there the integral of 2 plus e to the 3x, e to the x plus 1 with respect to x. So again, this one, because there are two terms on top, there's only one at the bottom, so you need to write that as 2e to the x plus 1 plus e to the 3x over e to the x plus 1. You can divide them first. And after that, this one could be written as what? The integral of 2e to the negative of x minus 1. dx. Okay? Plus the integral of e to the 3x minus x plus 1 dx. Okay? So this can be integrated now, but this one, let us simplify this further. So that is now e to the 2x minus 1 dx. This one is 2e to the negative x minus 1 dx. Again, so you can use substitution here. You can let your u as this, okay? However, because it's just a linear, when you take the derivative of that, it's negative 1, okay? When you take the derivative of that, it's 2. So therefore, we can just simply take the integral right away. So that is e to the negative x minus 1. That's the integral of this times the derivative of this is negative 1, then just have 1 over negative 1 there. Copy that 2, okay, plus copy your e to the 2x minus 1. The derivative of 2x minus 1 is 2, then you just take the reciprocal of that as 1 over 2, then that's the integral, sorry, number of this, plus your c. So therefore, let's rewrite it neatly. So that is negative 2 e negative x minus 1 plus 1 over 2 e to the 2x minus 1 plus c. That is the final answer.